In this next problem, we want to find out what this subscript is, X, in our chemical formula. The problem states we have 28.9% chlorine by mass. Another way of representing this mass percent is that there's 28.9 grams of chlorine per 100 grams of KClOx, part over whole. So our first step is we want to assume 100 gram sample of our KClOx. And our second step, if we're assuming 100 gram sample, we can take our 100 grams of our sample minus 28.9 grams of chlorine to get the amount of KNO, which is 71.1 grams of KNO in our compound. In our third step, we're going to determine the moles of K from the moles of Cl. And we can do that because there's a 1-to-1 mole ratio. The subscripts are 1 and 1, so it's a 1-to-1 mole ratio. So if we have 28.9 grams of chlorine, and for every 35.45 grams of chlorine, we have 1 mole of chlorine. And for every 1 mole of chlorine, there is 1 mole of K. So this ends up being 0.8152 moles of K. Fourth step, we want to determine the grams of K. So we have 0.8152 moles of K, and for every 1 mole of K, we have 39.0983 grams of K. So that gives us 31.87 grams of K. Fifth step, we want to determine the grams of O. So if we have 71.1 grams of K and O, we can subtract the 31.87 grams of K to get 39.23 grams of O. Okay, and then next we want to determine the moles of O. Okay, so if we have 39.23 grams of O, we can convert it to moles by using the molar mass, because 16 grams of O is to 1 mole of O. So this ends up being 2.452 moles of O. Okay, so now we can convert our moles, we can obtain our moles of chlorine as well. Because if we have 0.8152 moles of K, and we know it's a 1-to-1 mole ratio, 1 mole of K is for every 1 mole of Cl, that means we have the same number of moles, 0.8152 moles of Cl. Okay, so now we're going to divide by the smallest number of moles. We have K, 0.8152 moles. Cl, which is 0.8152 moles. And oxygen, 2.452 moles. So I've divided by the smallest number of moles, which is 0.8152. And if I divide by the smallest number of moles, my empirical formula is KClO3, which means that our X is equal to 3. In problem 4, we have a metal that is reacting with oxygen gas to produce a metal oxide. So this is a sketch of its chemical reaction that's occurring. And we have 7.503 grams of our metal. And what we want to find in this problem is the molar mass of this metal. And we know that molar mass of our metal is going to equal grams of our metal over moles of our metal. We have our grams that's given in the problem. So half the problem's done. 7.503 grams of N is the numerator. What we need to find is the moles of the metal. In order to find the moles of the metal, we're going to have to find the moles of oxygen. And we know according to this formula, it's a 1-to-1 mole ratio. You have 1 mole of M for every 1 mole of O. Okay, so what we're going to do is we have 10.498 grams of our metal oxide. We're going to subtract the amount of metal, which is 7.503 grams, to get the amount of oxygen, which is 2.995 grams of oxygen. Now that we have our grams of oxygen, which is 2.995 grams of oxygen, we're going to convert to moles of oxygen using the molar mass from the periodic table, which is 16. And we know that for every 1 mole of O, we have 1 mole of N. And so what we have here is 0.1872 moles of M. And that's going to be the denominator. So what we end up having is 7.503 grams of M over 0.1872 moles of M. So that's going to equal 40.08 grams per mole. And if you look at the periodic table, this is calcium. So this metal is calcium. The overall chemical reaction would look like calcium reacts with oxygen to produce calcium oxide. And we'll talk about balanced chemical reactions later on in our lecture.